So I know we haven't tested yet on chapter 3, but it fell with the review. Oh, there is another bell. It fell with the review on Thursday, Monday. And that's not really fair to you guys because you take it Thursday and the other group gets a whole other 4 days. Does that make sense? So Thursday, Monday is the worst. So I'm pushing the test to Monday, Tuesday of next week. So for you guys, it'll be on Tuesday. But I don't want to waste a day either. So I'm going to test 3-1 to 4-1. All right? So technically we're done with chapter 3. But we'll hit 4-1 today, and then we'll do review Wednesday, Thursday, and I'll have that for you before you leave today. It's being printed. There's also an extra credit, extra practice for the test as well, because the last test I had a couple people email me, do you have anything I can just practice on my own that's not this packet? And I didn't. So this chapter I made one, and I'll just count it as extra credit. With the review, I always give you enough time in class to do it, and then your job for prep for the test next week would be to study instead of doing a zillion problems, all right? So we're going to do 4-1. You'll finish it in class today, and then you can start the review if you want. 4-1 is nice and short. It looks intimidating because of all the words, but it's basically an exercise in reading here. So I'm going to, oh, by the way, any questions from yesterday's? Because that was kind of tricky. Anyone need me to go over any? Or if you do, ask me during the work time, because that was good practice for the test. And it was kind of hard. I did post the key though, so here we go. So chapter 4, you can see the title, Contextual Application. So we're finally going to start applying this stuff. So you'll notice if you look at your worksheet today, there's a lot of words. It's not just like use the quotient rule to find the derivative. Today's task is just going to be putting the derivative in context. So you're going to be reading and trying to figure out, where's my pen? Here it is. And trying to figure out what this particular derivative means in the context of this particular problem. So the math is going to be very, very, very easy. All right? But you're used to being given y as a function of x, and you're used to finding y prime or f prime of x or dy dx, correct? Now this x is going to almost always be time, but sometimes it's something else. But your independent variable is things changing over time. Like on this one, something's changing over time. So you're still going to want to think, I think, of x and y, but they won't be labeled that way anymore. And you're going to have to figure out, well, what does this mean? All right? In the context of the problem. There'll be minor computations, and we'll be using our calculators. So you should find your calculator because a lot of these, the actual math is calculator active. So you'll be able to just take the derivative on your calculator, all right? So the point of today's isn't to take derivatives, it's to know what it means. So I'm going to let you guys read this problem. I don't need to read it to you. Go ahead and take a minute to read what this table's giving you. So there's almost always going to be something being recorded, and usually over time. Did I give you enough time to read it? All right. So we're recording water temperature in a pond or lake, or maybe it's Lake Mille Lacs, or whatever, it doesn't matter, put it in context. Every 3 hours they're taking the temperature, okay? And if you were to graph it, let's go do it so you can see what happens. We'll just make a really cheesy W of t graph here. Notice I'm not labeling them x and y anymore. My t is in days, right? And my W of t is degrees Celsius. All right, so 0, it was 20 degrees. So let's put our 20 right here and just one dot. 3, it was 31, so it went up. 6, it was 28, so it went back down, right? 9, 7, 8, 9 is at 24. So back down, but not past the, I'm not making the best dots here. And then 22, and then 20, let's just go like this, 22, 21. The point is, These are just snapshots in time. You do not know what's happening between those two. Does that make sense? You can assume it's continuous, but with anything, you don't know what's happening between the two. When it says approximate W prime at 12, W of 12 is 22, and it's the second to the last dot I made. So I'm going to do that one in black, even though I made a really crappy graph. I have no clue what the derivative is there. I don't even know what the function's doing there. Does that make sense? However, I know what's happening next door, and we've talked about that to find the instantaneous rate of change. So let's write that. W prime at 12 is equal to the instantaneous rate of change at 12, which we can approximate, right, by doing the average rate of change as close to it as possible. So that we talked about, and we did it on the last test, and it's super easy. But when it says show computations that lead to your answer, our W prime of 12 would be the slope of the secant line as close as possible. So we're going to straddle it, and we are going to do change in Y, which is change in water temperature, over change in X, which is change in time. So we'll just go 21 minus 24 over 15 minus 9. So it looks like I have a -3/6 or a -1/2. All right, so this was an actual AP Part A question. It is worth 2 points. Notice one of them says for the difference quotient. That's for showing this. You have to show the computations that lead to your answer. The other is for your units, because it says answer with units. So you have to know how to label it, right? And you label it top per bottom. So what will I label mine? What was the top of this? It's no longer Y, it's temperature, right? In degrees Celsius, so put degrees Celsius per day. It's always Y per X. So for your label, degrees Celsius per day, or what's changing over what's changing. Almost always this will be time, but there's going to be, I found an example where it wasn't, but it was really hard. All right, so almost always that's a change in time. One thing you have to think about with these guidelines for interpreting the meaning is that you have to figure out what your noun is. So in this case, what was I trying to find? So the subject of this problem was temperature or degrees Celsius that was changing. My units, it's always Y per X, but for us, it's always going to be some function of time per time, except for one of them that I found. All right, but it's always like per day, per second, per hour, or per whatever this is. I did find one with wind chill, and it was a function of the velocity of the wind. So we were putting the velocity of the wind in to the function, so that was the only one I could find where it wasn't something changing over time. So if you were to interpret the meaning of that derivative, okay, our W prime at 12, we approximate it to be -1/2, right, degrees Celsius per, was it hour? Day, right, per day. All right, what does that mean? We have to use the noun, the units, and the time when you interpret it. So whenever you're asked to interpret the meaning of your answer, you have to reference the degrees Celsius, you have to put the appropriate units, and you have to say at what particular time it is. So think of nuts, noun, units, time. So, and it doesn't matter what order. So I like to kind of start with the time. I would say at t = 12 days, now I need the noun. What's changing in this problem? Temperature. Temperature is, now here's where you have to be careful. Because it was negative, it was going down on average, right? But if you're going to use the word decreasing, then you'd say decreasing by 1/2. Don't say decreasing by -1/2. So it's safer to say changing and just leave the sign in here. Because what kids do, I've been a reader for these, and there's so many kids like across the world who say decreasing at a rate of -5. You're like, no. Do you see the problem? Then, so if you're going to use the word decreasing, it absorbs the negative. So it's decreasing by a +1/2. Or just say temp is changing. Then you don't have to worry about it. At a rate. And derivatives are always rates. So kind of think about that. When they ask you to interpret it, you should have the word rate in there. At a rate of -1/2 degrees Celsius per day. The math on that, Quinn, was so easy, right? It's this that you'd be surprised. That's a struggle for a lot of people to get that interpretation down there correctly. So we're going to practice 2 more, and then that's it for today. This was on the 2013 exam, which was the second year I taught calculus. And keep in mind, there was a part B and a part C, but it was on integration, and we don't know how to do that yet. But the first question, again, I'm going to let you guys read the problem, and it is calculator active, so take out your calculators. Wrap your brain around the problem. Did I give you enough time? All right, so here's what we have. We have 500 tons of unprocessed gravel sitting at a gravel plant, like that one that's right on the north side of Elk River. Let's see, there's a big gravel plant over there, right? Suppose it opens this morning at 9 o'clock, okay? And what's happening is, I used to always tell kids with these types, they're actually called right in, right out. Here's my truck. It's beautiful, isn't it? These trucks are coming in, and they are dropping gravel off, right? But look at what it says, at a rate in tons per hour. That's super important. This G of T does not have the prime symbol on it, right? But it's still a rate. It's a derivative. They're telling you with the words that G is already a derivative. It's the rate in tons per hour that it's being dropped off. So keep that in mind. You already have the rate at which it's being dropped off. All right, here we go. And there's already 500 tons there. You don't need to worry about the rest of it because it was for part B and C. When it says find G prime of 5, they just do want you to take the derivative of this. Really, it's the second derivative contextually because we already had a rate, right? You can go to your calculator though because this was calculator active. Do you guys remember what button to hit? It's been a while. All right, so I'm going to go to my calculator and I'll show you, remind you where that is. So it's math 8, takes numerical derivatives. Now you're not going to put a t in there, we're just going to put an x in there. This is a function of time, but you don't need to go use your, whoops, and then you go put the function in the parentheses. This was 90 plus 45 cosine t squared, so we do x squared, and then we're going to divide it by 18. There we go. And at the specific time, because t is the new x, right? But your calculator's fine, it doesn't know, right? So you put a little 5 right there. Be careful that you're in Radian mode because this is a trig problem, and we're always in radian. So I'm going to check my mode because I do help with geometry. So I do go to degrees sometimes, but I'm good. But you should check the modes on your calculator. Go ahead and hit enter. Got it? Okay. Now, what do we round to? Do you remember, Lane? 3. Yes, a minimum of 3. You're allowed to truncate at 3 or round at 3 or go beyond 3, but you can't go -24.59. You won't get the answer point. So I'm going to go -24 point, I forgot it. Can you help me out, Quinn? 588. All right, that's my first point. That was easy, right? Because my calculator just did it. So that was an easy point, right, Sam? Now, it also says that I'm supposed to use correct units. Now be careful because this means another rate or another per. All right? We have to reference the noun, what's changing, right? The correct units and the time. All right, so here we go. That's my answer. I got this 1 point right here. But to get the other point, I need to interpret that. So I'm going to start with the time. At t equals 5. 5 what? Was it hours? Okay, at t equals 5 hours, what is changing in this problem? See what I mean? It's kind of tricky, right? What did we just take the derivative of? The rate. Yes, the rate at which. Now, if you don't want to, you can say at which G is changing. You can say that. Or you can say at which the gravel is arriving at the plant, because that's what G is. All right? So I'm going to be more specific. The rate at which gravel, because it says that's what G is charting. The rate at which gravel is arriving at the plant is, all right, so t equals 5 hours. The rate at which gravel is arriving at the plant is, you can put decreasing. It just means it's arriving slower than it had been. It's still arriving at the plant, but maybe it's lunchtime or something. You know what I mean? And it's arriving slower. That's what this means to have a negative rate of it, is it's slowing down. So at t equals 5 hours, the rate at which gravel is arriving at the plant is. If you use the word decreasing, then don't put a negative. So what did I suggest you use instead? Changing. Thank you, guys. Plant is changing at a rate of negative 24.588. Now watch with the label. So many kids got the label wrong on this. And you'd think it'd be so easy. It's just a label. But the original one was in tons per hour. And I just took its derivative. And every time you take a derivative, it's the word per. So it's tons per hour per hour. All right? It's like acceleration in physics. Miles or feet per second per second. Are any of you guys in physics? And when you label your acceleration, isn't it like feet per second squared? It's the rate at which a rate is changing. Okay? Negative 25, 5.55, what was it? Tons per hour was what the original function's label was. But we took the derivative, per hour. Or sometimes it'll say tons per hour squared. Some kids do that. Guess what most kids across the world, I was a grader for this one. Guess what most kids across the world label this? Tons per hour. It was so easy to score because I just go right to that label because it says with label. And if the label was off, I didn't even read what they wrote. So it's kind of sometimes you get stuck on a really hard one, but they advise, they brief you for like 2 hours on how to score your particular problem, and then you score only one problem. Like you don't score a full test. So I was on this one for like 3 days. So you read it over and over again, but they said if it says with units, go right here, and if it's off, you don't even need to read what they wrote. So units are very important. Are you guys good at why it was tons per hour? Per hour, because the original function was a rate. All right, last one. And again, I tried to pick hard ones, so because some are really easy, but that one was tricky because it was a rate that was changing. It's kind of like acceleration. Is your velocity that's changing, correct? So let's go to the next one. It's also calculator active. So you can also just go W prime of 20 equals, I'm not even reading the problem yet because I've got a function. I'm on my calculator active problem and I'm being asked to take a derivative. So I go immediately hit the Math 8 button. You guys go take it. And that'll give me the value. And then we'll get our brain wrapped around what this problem is. Can you guys tell me so I don't have to go to my calculator?
Negative 2.86.
One more decimal place.
No, 0.286.
Oh,
Sorry.
negative 0.286. Do you guys back him on that? Okay, great. Thank you. That got me the first point. That was easy. Right? Now, I have to go wrap my brain around this problem. The wind chill is the temperature in degrees Fahrenheit. Okay, so that's the wind chill that a human feels based on the air temperature in degrees Fahrenheit and the wind velocity in miles per hour. Right? So this guy right here, the velocity is going into the W function to give us our wind chill. Does that make sense? And the higher the velocity, right, the lower the wind chill. If the wind's really whipping out there and it's 10 degrees, they'll say feels like 20 below, right? And this is a function that'll spit that out if you just put in the velocity. All right, so remember, we do x and then y, and it's y per x, correct? This problem is v going into w. Does that make sense? So it's w per v. And what did it say the wind is measured in? Degrees what? Fahrenheit. So this is degrees Fahrenheit per. It's a very weird label, but it is what it is. Per, and what is this labeled in? Because we took a derivative, so you need per. Per miles per hour. Degrees Fahrenheit per mile per hour. Degrees Fahrenheit per miles per hour. Now, would I get the full point for this? Go ahead and read the scoring stem. Like when I was reading, I didn't actually read for this one. I didn't start reading until 2013, actually. If I were, would I give the kid 2 points or 1 right now? 1, right? I've got the label, but I haven't explained what it means yet. Okay, so nuts, and I always start with the T, because that's what, I tend to forget the time if I leave it till the end. So I would say at, but it's not time this time, right? So I think I'll say when the velocity is 20 what? Miles per hour. You actually don't need to put the label there if you put it on up there. It's just got to be somewhere. But so you could just say when 20 is 20 because we got that over here. But when the velocity is 20 miles per hour, what's changing in this problem? The wind chill or the temperature, you can say. You can reference it either way, but that's what this is. The subject of this problem is the W. That's what we're answering, right? The wind temperature, or what did they call it? The wind chill, let's do that, is changing at a rate. Every derivative is a rate of change, right, of negative 0.286, or you could say decreasing at a rate of, and you don't actually have to label it again since we already did. Like if I was grading this one, I'm going to check for the value and then an explanation with a label somewhere. And I have the label up here, but I'm just going to degrees Fahrenheit per mile per hour. We are done. That was weird math, wasn't it? So you're going to be starting to do word problems where you're going to be taking derivatives either by hand or on your calculator. And the more important thing is, what am I finding? Because everything in the world is changing over time, correct? And if you're going to be an engineer and you're a mechanical engineer, there's bolts changing over time. You know what I mean? Everything's changing. If you're a civil engineer, you've got like the wind changing with the windmill going. It's everything. So more important than knowing how to take these derivatives, which is what chapter 3 and 2 are all about. Chapter 4 is going to be, now how do I apply this? And this was just on what does it mean. All right, so we're done with 4.1. Your assignment is this 4.1 worksheet, and it's basically just 1, 2, I think there's it looks like there's 6 of them. And you just have to find it either on your calculator or by hand, depending on what it says. It's multiple choice, so you have to read, but I think you'll find it pretty easy. Yeah. So 4.1, you guys can turn it in when you're done, because you'll finish this in well under a half an hour. Actually, more than a half an hour. And I'll go grab the review, because some of you might want to start that. Do you wanna do one together, just to, let's do it, and then I'll turn off my thing. So actually I'll turn it off right now, just a sec.